Welcome to another Algebra 2 lesson. This is lesson 5.3. Our objective, graph radical functions using tables and transformations. Here's a review of your transformations that we learned previously in chapters 1, 2, and 4. Quadratic functions. X squareds describe the transformation that's been done to the parent function of the quadratic, represented by G. Remember, x squared is a quadratic function. Quartic is x to the fourth. Quadratic is x squared. X squared minus 9, what does the minus 9 do? Subtracting 9. Write down what you think your answer is. Number 2, what does the 1/4 do? What does the plus 5 do? Remember, adding or subtracting is a vertical translation. Subtracting is down, adding is up. Multiplying by a 1/4 is a vertical shrink by 1/4. Here's your next two. Write down what you think those transformations do to the x squared. Check your answers. Multiplying is a shrink. Multiplying by a number less than 1/2. That's a vertical shrink. And this one was a translation down 1/2. Next two. Plus 3. What does that do? Multiplying by negative. What does that give us? And then multiplying by 2 and adding 1. Write down those 3 transformations for number 6. Only one of them here for number 5. Then check your answers. So here's how transformations apply to quadratics. We are going to extend that to new kinds of functions today. Use a graphing calculator to graph the following equations. Use the math button to find nth roots. Match each function with its graph. You can also graph these on Desmos. A square root just goes from 0, 0 and up and over to the right, up and over to the right. A cube root can use positive and negative numbers for x's and y's. A fourth root, that's got to be all positive x's, which will give us positive y's. Fifth root, that can use positive and negatives. Remember, for even roots, we can only put a positive number underneath an even root. So these two have to be even roots. These two have to be odd roots. Pause your video, see if you can match those up. All right, A and D are pretty similar, but this one has to be the square root and this one has to be the fourth root, because if you look at the ends, the square root's going to be of, say, 6 is going to be a higher number than the fourth root of 6. And this one goes a little bit higher than this one does. So we have a square root here, fourth root here. By comparing the ends of these odd roots, the cube root and the fifth root, we can see that this one that's a little bit lower has to be the fifth root. The other one is the cube root. So that's the general shape. What about domain and range? Well, the domain and range of the square root and fourth roots both have to be greater than or equal to 0. X has to be greater than or equal to 0, and y has to be greater than or equal to 0. For the cube root and the fifth root, you can have all real numbers for domain and range. Those can use the negative numbers. What about these? Now let's match these up with the square root of x. So the square root of x, let's go back for a minute. Square root of x looked like this one. This one right here, D. Started from 0, 0, went up and over to the right. So think about your transformations, plus 2 on the inside, That's going to go left. Minus 2 on the inside, that's going to go right. Plus 2 and a minus 2 on the outside. Ooh, a minus 2 on the outside is going to go down. And this one's has a negative, but it also has a plus 2 on the inside. So this one's going to go left, and it's going to flip over. All right, pause your video. Map these up, ABCD with ABCD. Write it down. There's your answers. A went with A, little b went with big D, little c went with big B, and little d went with big C. I also wrote some notes. This one went left, this one went right. Third one went left and down, so that went with B. Let's see, let's look at B. Left and down. So if you just take that main point that starts from origin, when you go to shift it, this left and down, you just move it 2 units to the left and then 2 units down. So 2 units left and 2 units down. Looks kind of like that. All right, so that's how it applies. The transformation rules apply to radicals. Parent functions for square root and cube root functions. The parent function for the family of square root functions is f of x equals the square root of x. Your domain, x is greater than or equal to 0. The range is y has to be greater than or equal to 0. Because remember, the square root of a negative number is imaginary, and we only graph real numbers. The parent function for the family of cube root functions is cube root of x. Cube root and all other odd roots look like this. They go through 0, 0, 1, 1, negative 1, negative 1. But then if you think about 8, the cube root of 8 is 2, because 2 times 2 times 2 is 8. So way out at 8, 4, 5, 6, 7, 8, it would finally get to 2. So that's why it's so narrow. It's got to head out towards that. All right, but notice your domain and range, all real numbers. We have to come back to this later when they ask about domain and range. Graph each function. Identify the domain and range of each function. F of x equals square root of 1/4 times x. Let's make a table of values and then make our graph. Look at the numbers I chose. They're all multiples of 4. I did that because I have a 1/4 x, and I can pick any x's I want. You can choose any x's you want to make your graph. Well, I picked multiples of 4 so that it would be easier to multiply by 1/4. So multiples of the denominator will help you get rid of your fractions. So that's just a little shortcut. Make things easier on yourself. Okay, negative 4 times 1/4. 1/4 of negative 4 is negative 1. The square root of negative 1, well, that's undefined. So there will be no graph over where x is negative. Well, how about 0? 1/4 times 0 is 0. Square root of 0. 1/4 of 4 is 1. Square root of 1 is 1. 8. 1/4 of 8 is 2. What's the square root of 2? I had to use a calculator and get an estimate, but I've done it so much in the past I have this one memorized. Square root of 2 is about 1.4. The next one, 12. 1/4 of 12 is 3, same as 12 divided by 4. And then the square root of 3, 1.7. So let's make our graph. There's our graph. What's our domain and range? Is it all real numbers? Is it all real numbers? Nope. It has an arrow. I put an arrow on this end. This end is an endpoint. It doesn't keep going over here. So our domain has to be x is greater than 0, greater than or equal to 0, and our range goes from 0 up. Our x's go from 0 over, so they're both greater than or equal to 0. And that's example 1A. We made a table, put them into our equation one at a time, solve for what y is. F of x, remember, is just our y value. F of x, that's where our y's are, and graph it. All right, next one. Example 1B, -3 times the cube root of x. Now, I didn't have a fraction in this one, so I chose my numbers by using numbers that I know the cube root of. The cube root of 0 is 0, the cube root of 1 is 1, the cube root of 8, well, 2 times 2 times 2 is 8. So I know that one. So you put these in one at a time. We have -3 times the cube root of -8. -8 is -2 times -2 times -2. So the cube root of -8 is -2. -3 times -2 is +6. Do the same thing, but with -1. So instead of a -8 now, we put 1. Put a 1 in here. Whatever value we're using for x is what goes in for x into the equation, and then figure out what that equals. Make your table, make your graph, write down your domain and range. Putting those numbers in one at a time. Here's what you get. Make your graph. And remember, they're curves, they're not lines. So I kind of think of, in my mind, I tell myself it's a half a parabola when I do each one of these halves. I've drawn parabolas more than I have cubic graphs or cube roots. But notice this is a flip. The negative was a reflection over the x-axis from the parent function, and the 3 gave it a vertical stretch. So if we compare that to the parent function, here's the parent function. It flipped over the x-axis, so this is down and this is up, and it stretched, so it went out further than the original parent function. There it is. And then our domain is all real numbers, and our range is all real numbers. On big ideas, you probably have to put in the words all real numbers, would be my guess. Or it's a drop-down menu, but it's all real numbers. You can, if you're doing it in writing, do a capital R with the extra little line. And that's example 1, graphing roots. Here's how all of the transformations apply to our radical functions. Right, left, and it gives you lots of examples of right, left, up, down. Inside with a negative is a reflection in the y-axis. A negative on the outside is a reflection in the x-axis. Horizontal stretches or shrinks. Remember, this is the reciprocal. Here's one of the hard ones. It's inside, it's ×3, but it's a shrink, a horizontal shrink. It says horizontal way over here. Horizontal shrink by a factor of 1/3. If it has a fraction inside, it's a horizontal stretch by a factor of 2. If we're multiplying on the outside, this is a vertical stretch by a factor of 4. And this one is less than 1. So it's a vertical shrink by a factor of 1/5. You have to know your transformations. All right, describe the transformation represented of F represented by G. Check your answer using a calculator or Desmos so that you can look at the graph, see what it did. Identify the domain and range. All right, what does the -3 do? What does the +4 do? Write it down. It's a square root. So that's going to affect our domain and range. Okay, so what does the minus 3 do? All right, so horizontal translation, right 3, vertical translation, up 4. For the domain, the stuff inside the radical, x minus 3, has to be greater than or equal to 0. So for this to be true, what does x have to be? We need to solve this. Add 3 to both sides. So x has to be greater than or equal to 3. That is our domain. The range. Well, we need to figure out where is this going to start from. So let's think about a graph for a minute. This is, for example, 2a. It went right 3 and up 4. Right 3, 1, 2, 3, and up 1, 2, 3, 4. And then it's going to make that little curve. So it's going from 3, the point 3, 4, and then going over to the right. So notice x has to be greater than or equal to 3 from here forward, and it's going to go from here up. So for our range, the y values have to be greater than or equal to 4. Really helpful to think about what the graph looks like. All right, cube root of x, compare that to a cube root of negative 8x. Well, our domain and range is going to be all real numbers. It's a cube root. We can do positives, we can use negatives, everything's good on those. That's the easy part when you have an odd root, cube root, fifth root, seventh root. All right, now, what does the negative do? What does the 8 do? What do you think? They're both inside, so that's a horizontal shrink by the reciprocal of 8, that's 1/8. And it's also inside, so that's a horizontal in-house motion, flipping left and right. That's a reflection over the y-axis. And domain and range are all real numbers. And that's example 2. You can also look at your graph on Desmos, and that can help you decide as well. When you use Desmos to figure out what the transformations are, I highly recommend that you graph the parent function and the new function so you can compare the differences. Example 3, the function e of d equals 0.25 times the square root of d approximates the number of seconds it takes a dropped object to fall d feet on Earth. The function m of d approximates the number of seconds it takes a dropped object to fall d feet on Mars. Write a rule for m. Okay, so we have two functions. We have e of d, we have m of d. We have Earth, we have Mars. Notice that this function for Mars compares it to Earth. So it's 1.6 times what the Earth function is. So in place of e of d, we're going to put in the Earth function. So 1.6 times 0.25 times the square root of d. You want to simplify this a little? Grab a calculator. 1.6 times 0.25. 0.4 times the square root of d. So that is our rule for m. How long does it take a dropped object to fall 64 feet on Mars? So feet is d. D is 64. We need to use that equation for Mars. 0.4 times the square root of 64. So remember, this equation estimates the number of seconds. So m of d, or the number of seconds, equals square root of 64 is 8 times 0.4 is 3.2. And they told us that was number of seconds, so 3.2 seconds. So this is one way to think of a transformation. They gave us an equation, a function for Earth, and then the equation for Mars was relative to what happens on Earth. Combine the two functions, and we get a new function that gives us the time it would take something to fall on Mars. Example 4. Let the graph of G be a horizontal shrink by a factor of 1/6, followed by, so make sure we do this transformation first, followed by a translation 3 units to the left of the graph of f of x equals cube root of x. Write a rule for G. So here's our starting function. Got to do a horizontal shrink by 1/6, and then 3 units to the left. Horizontal shrink. Horizontal's in the house. Inside. In this case, that's going to be inside the radical, and we have to do the reciprocal. So the reciprocal of 1/6 is 6. We've completed that, followed by a translation 3 units to the left. Now, when we go to left or right, it has to go just to the x number. X minus 3. Subtract 3 from just x. And there's our function. There's just not enough practice in these examples, so let's try 2 more. Read through these, write down what your answer is. This one, they are not starting with a parent function. They are starting with a different function. So that's why I've added these in. Find your transformations, reflection in the y-axis, followed by a translation 1 unit right of this graph. Number 44, 1 unit down, 5 units right, followed by, oh goodness, a reflection in the x-axis. All right, pause your video, give them a try. These are the hard ones. These are the tough ones, but we need to be able to do these. The more we practice, the better we get. Pause your video, write down some answers. Reflection in the y-axis, multiply just to the x by -1. Reflection in the y-axis, that's where we do f of -x. So replace your x with a -x, followed by a translation 1 unit to the right. One unit to the right, we're going to subtract 1 from just the x, and now we need to simplify. -x plus 1, distributing that negative, and then a -1 plus 1 minus 1 goes away. Final answer, y equals 2 times the cube root of -x. All right, try 44. One unit down, subtract 1. 5 units to the right, subtract 5 from just the x, followed by, okay, so we should actually simplify all of this before we do the followed by. But the followed by is a reflection in the x-axis. So ultimately, that's going to be multiplying everything by a negative. So let's not do that just yet. X minus 5. We do have some simplifying here to do. Plus 3 halves minus 1. Well, 3 halves, take away 1. 1 is the same as 2 halves. 3 halves minus 2 halves is 1 half. So we have a positive 1 half. And then because of the reflection, this is going to become a negative. The opposite of a negative and a positive will become a positive and a negative. And there it is. Check your answer. And that's it for our examples for 5.3. Now you get to work on your big ideas assignment 5.3. Have a great day. Thanks for watching.